problem 798, smallest rotation with the highest score. So the idea is that we are giving an array nums, so we can rotate it by a non-negative integer k, so that the array becomes like nums k plus 1, yeah, etc. until to n minus 1 to 0, 1, k minus 1. Afterwards, any entries that are less than or equal to their index are worth 1 point. Yeah, so we just need to understand what's the meaning about this one. So it means if the current number is less than or equal to the index, we're gonna increase the score by 1. Yeah, let's just try to use this example, try to understand what is the meaning of the question first, and then try to find a method to solve the problem. Yeah. So we have this kind of number like 24130. So, and we're gonna rotate it by k equal to 2. Yeah. So if we rotate it, we're gonna rotate it to the left. Yeah. So if k equal to 2, it means this 2 will go here, this 4 will go here. So it's gonna be rotated 2 places. It's going to be 1, 3, 0, 2, and 4. Yeah. So this is going to be the k equal to 2. But from here, this was 3 points. Yeah, because we just needed to check the index. This is going to be the index 0, 1, 2, 3, 4. So if the index is more than or equal to the current number, so we're going to count it. Yeah. So 2 is more than or equal to 0, 3 is more than or equal to 2, and 4 is more than or equal to 4. So we have 3 points because 1 is less than 3, 0 is less than 1. Yeah, but for this 2, for 3, for this index, if the index is more than or equal to the current number, so we're going to count it as 1 score. So we have 3 scores, so we're going to return 3, and this one going to be, if this is the maximum, so we're going to return the maximum of the index. Yeah, we're going to return this 2. So yeah, so basically, this index just means how many rotations. So basically, we're gonna return this 2 if k equal to 2. We're gonna return this 2 if we get the maximum value. So this is just the meaning. So we're gonna return the rotation index k that corresponds to the highest score we can achieve if we rotate the nums by it. So if there are multiple answers, we're gonna return the smallest index k. Yeah. So if we find multiple answers, which is, for example, the score is also 3, but we're gonna return the first one. Yeah, we're gonna return the smallest index. We're gonna return the smallest index k. Yeah, so this is just the idea of the description. This is just the description of the problem. Now, we want to analyze this problem. How can we find a better way to solve it? Because definitely we're gonna use the O(n) time or n log n time to solve the problem. We cannot use n squared to solve it. Yeah, because n is like 10 to the power of 5. Let's just check that. Yeah, because n is 10 to the power of 5. Basically, maybe we're going to use O(n) or n log n time to solve the problem. And also, let's just check the nums. Yeah, so if we have some nums like this one, 24130, and let's just check the nums, and also for the nums. Yeah, so for the value of the nums, it is always less than the length of the array nums. So if the array nums is n, and this value is always less than n, and this is very important for the problem. Otherwise, we cannot solve it. Yeah. So for example, if the length of the array in this example it is 5, it means the value can never be more than or equal to 5. It should always be less than or equal to 5. Otherwise, we cannot solve the problem. Yeah. So this is just some intuition from the concrete and the descriptions. So for this problem, we're gonna enumerate the values one by one and to check that if we can get a final result. Let's just try to some testing cases. So for example, we're gonna prepare some index like 0, 1, 2, 3, 4, and 5, 6. So we're gonna have an array, and the length gonna be 6, currently let's just the length of the array gonna be 7 because we have so n equal to 7. N equal to 7, it means the length of the array is 7, and we're gonna have 6 index. And we have some numbers. Yeah, so we don't care. We don't care which number it is, but definitely this number will always be less than equal to 6. Yeah, less than the length less than 7, so it should be less than equal to 6. So let's just try to check some numbers. Maybe from here we want to check this number, maybe it is 4. And for all other numbers it doesn't matter because we don't care currently. Yeah, we just take care of this number 4. Yeah, because according to this number 4, maybe we can find some intuitions to solve the problem. Yeah, because the array will be sorted. Because the array will be rotated to the left side. Yeah, but the index from 0 to 6 is going to be fixed. So the index is going to always be like 0, 1, 2 until 6. And the index will always be increasing. So there are two intuitions. So the index is fixed. And the index is always increasing because index is 0, 1, 2, 3, 4 until 6. So it is increasing. And the index is also fixed. It is 0 to 6. Yeah. So there are two intuitions of the index. Yeah, but up to now, the numbers we're gonna fix it. So the numbers, for example, this 4 will be fixed to here. But after that, we're gonna rotate it. Yeah. So if we fix this number 4 here, so 4 is at this place in index 2, and we're gonna check this number. Yeah, maybe let's just try to check another case first, because this case will be a little bit harder. Let me just check another case, check the easier case, just to check this number. The index is more than and equal to this number. Yeah. So let me put 2 here maybe. Yeah. So if I put a number 2 here, so this means the index is more than and equal to this number. So this 4 is more than and equal to this number 2. Yeah. So if this number, the index is more than and equal to this number, basically we want to find how many ones or how many zeros for the score. So for this 2. Yeah. But for this 2, it will be rotated to the left. Yeah. So currently we're going to consider this 2. And we're going to put it in the first position. So currently 4 is more than and equal to 2, so we're going to record it as 1. And after 1 rotation, 2 will go to 3. Yeah, so if 2 goes to index 3, it is still 3 more than and equal to 2, it is 1. 2 is more than and equal to 2, it is 1. But for this 1, it is less than 2, so we're going to record it as 0. And for this 0, we're going to record it as 0. And after that, we're going to have 6 and 5. So because 6 and 5 will definitely be more than and equal to 2, so we're going to record it as 1 and 1. Yeah. So after that, we might find some intuition. There are some contiguous of zeros and ones. Yeah, as you can see here, we have 3 ones, and here we have 2 0, here we have 2 1. Maybe let's also try to use another, add more examples. Maybe this number we have also we have another number, maybe 2 here. Yeah, now we're gonna rotate it to the left. Yeah, because from the beginning this 2 is here, the position is here, and for this 2, yeah, compare with this 3, and the position will also be here. Yeah, this will gonna be 1 1 because this 2 moves here, and then 2 moves here, it's gonna be 0 0. After that, 2 will be here, here, and here. So it's gonna be 1 1 1. Yeah. So what intuitions we have found? Yeah. So whenever we have this kind of rotations, basically there will be some contiguous of 1s and contiguous of 0s. And if we fix one number, it is this one, and if we find another number 2, it is this one. And if we accumulate all the values, for example, this value 1 plus 1, it's going to be 2. Yeah, so if we only have 2 numbers, basically, what is our score? It will be 2. We just need to plus the first array and plus the second array, and the value would be, yeah, aligned the value, and this value plus this one plus this one, this one plus 1. Yeah. If we want to calculate some value inside 2 arrays, so array is fixed, we just need to plus the value in a range. So for example, this is a index 0 to 2, and this is the index 0 to 1, and this is the index, for example, this is the index 5 to 6, and index 4 to 6. Yeah, we just need to accumulate such values, so we can use a difference array to solve the problem, because there will be contiguous of 1s and contiguous of 0s. Yeah. Now let's just try to find the index. How can we find all the index? Yeah, I think we need to find. Let me just clean up a little bit. Yeah. Now let's just focus on this example with this number 2 at index 4. Yeah. Let's just use this example to find all the positions. Yeah. Definitely for this one. So if this 4 is more than and equal to this number 2, definitely from the beginning it will be a 1, because we will code it as 1, but we don't know how many ones. Yeah, definitely we need to know why there will be like 3 ones. Yeah, and we can use some mathematical calculation to solve the problem, to find the position. Basically we want to find this position, because for difference array, here gonna be a +1, but for this 0 it's gonna be a -1. And this is for difference array. So from the beginning, we have the first position and it's going to be index 0. So this is okay. We don't need to find it. But definitely we need to find this position. And how can we find it? We just need to check. Yeah. So this number 4 is more than and equal to, the index 4 is more than and equal to this number 2. We just need to check how many numbers from the left side, starting from this 4, go to the left side, how many numbers that will be more than and equal to 2. So we're going to use the current number. So it's going to be, this number going to be v minus the, yeah, I did it wrong. Let me, so it's going to be the index I. Currently the I going to be 4, minus this number going to be v. So I minus this number v, 4 minus 2, so it's gonna plus a 1. So this means we're gonna have 3 ones. Yeah, so this is because definitely 2, 3, 4 is gonna be more than and equal to this number 2. So we're gonna just use this number to minus the current number, the index minus the current number, but we need to plus 1. Yeah, this is just a mathematical calculation. So this means from here, this position gonna be I minus v plus 1. So this gonna be the position. So for here, it's gonna be a -1 for the difference array. Now we just need to find another position, because here gonna be a +1. And how can we find this position? Definitely here we have this kind of number 2 and this index. Yeah, we have this number 2, and currently we have the index 4. But after this index 4, it's going to be index 5 and 6. Yeah. So for the index 5, basically after to the right side, this index 5 definitely it will be more than the index 4. We just need to check how many of them. Yeah, but we don't need to check how many of them. We just need to find the positions. So this position for the index 4, it is I. So it means the next one is going to be I plus 1. So here it's going to be I plus 1. Yeah, because here is 0, index 0, and here is index I minus v plus 1, and here for this index it's going to be I plus 1, because here is I. Yeah. So this is the first calculation we find. Yeah, let me just record it, otherwise I will forget it. Let me just remember it's going to be something like 0, I minus v plus 1, and I plus 1. So it's going to be, the first one is going to be 0, I plus v minus 1, and I plus 1. And this is for the first case, case 1. Case 1, it means the current number, the index is more than and equal to the current number. yeah, we have this kind of intuition. Now let's go to the second case. So for the case 2, it's going to be I less than the current number v, and let's check what we can get for the second case. Currently I don't have any more drawings. Let me draw it again. But we're going to use another case. So the index is going to be similar, 0, 1, 2, 3, 4, 5, and 6. But the numbers will be different. Here, we're going to have the current number. It's going to be, so the index will be less than the current number. So we're going to check this number 4, similarly. And the length of the array is also 7, because the index is from 0 to 6. Yeah. Now, let's start to find some intuitions about this one. So definitely from here, because the index I is less than the current number, it's going to be starting from 0, and definitely for 1, it should be less than 4, it's going to be 0 and 0. But after that, we should know that the index is going to be more than this number. Yeah, so 6 is more than 4, it's going to be 1, 5 more than 4, 4 more than and equal to 4, but for this 3 is less than 4, so here going to be 0. Yeah, so this is our second case. This means the index is less than the current number. So first of all, from the beginning we're going to have some zeros, but for zeros we don't. It doesn't matter, because for difference array we don't count zeros, we only check ones. It means from here, for the difference array, we're going to have a +1, and from here, after this one, here is a 0, we're going to have a -1. But definitely we need to find the places, this one and this one. How can we find the places? Yeah. So for this index, the index is 2, is less than the current number. But to the left side, all those indexes like 0 and 1 should also less than the current number 4. And we just need to check how many numbers. 0, 1, 2. So it means it's going to be 3 numbers. So the starting position going to be just I plus 1. So this is going to be the starting position here, this one. And now we just need to check to know how many ones. Definitely there are 3 ones, but we need to count it. Yeah. So for our array, the length of the array is 7, so we're going to use n. This is our array. Yeah. And we want to check just how many ones. Yeah. And currently for this number, we have this number 4. So this means this n minus 4 minus the current number, we're going to call it v. We're going to call it v. So n minus v, 7 minus 4, it's going to be 3. It means it means we have 3 numbers. It's going to be more than or equal to 4. Basically, it's going to be 3 indexes. It's going to be index 4, 5, and 6. Yeah. So it's going to be n minus v. It means we have 3 numbers. But where we are starting from? We are starting from I plus 1. So it means this position going to be I plus 1 plus n minus v. This is how many numbers. Yeah. So for example, this I plus 1, the index is 3. So here I plus 1 is 3, n is 7. So plus 7 minus this v is 4. Yeah. So it's going to be 6. Yeah. So 3 plus 7, 10 minus 4, it's going to be 6. So 6 is going to be here. So this is exactly the index where we are. So we need to have this index set it as -1. Yeah, definitely it's going to be something like I plus 1 plus n minus v. I think this formula should be okay. It's just mathematical calculations of how many of them, because we are starting at this position. Basically, if we plus how many numbers of them, it means we have 1 more number. Yeah, but for our difference array, exactly, we just needed to have that 1 more number. Yeah, maybe we needed to use a -1. This is exactly like index 3 to 5. But for difference array, we needed to plus another 1. So -1 plus 1 is going to be 0. So we just needed to use I plus 1 plus n minus v. Yeah. Now let's just check the second case. So the case 2, if I is less than v, and we get the separate positions, separate point, it's going to be I plus 1 and I plus 1 plus n minus v. Yeah. So for this 0, let's just check for this first one. For this 0, we have plus 1, and for this I plus v minus 1, we have minus 1, and from I plus 1, we have plus 1. Let's check the second one. So from here, I plus 1, for the second case, we have a plus 1, and for I plus 1 plus n minus v, what we calculated, it's going to be minus 1. So if we get those two kind of formulas, basically we've solved the problem. Yeah, I think this is one of the difficult part of the difference array problems, and we have to practice a lot to find the separate positions, like here. Yeah, like here we have 3 contiguous zeros, contiguous ones, and contiguous zeros, and all the conditions will be like this. We have these areas will be 0, and these areas will be 1, and this area will be 0. Yeah. Yeah, and we only need to find this position and this position. Yeah, and for this case, we just need to find this position here and this position here. Yeah. Now let's just try to code it up from the two formulas. From beginning, we're gonna prepare the length of the nums, and then we're gonna prepare the difference array. For difference array, we're gonna prepare actual positions, because that one is just for calculation. This is n plus 1. This one is only for easy for the calculation. Now we want to check all the numbers. So for iv, enumerate the nums array, and we want to check the index I. If this is more than or equal to v, we're going to calculate the difference array. So f0, so this is 0, gonna be plus equal to 1. And fi plus v minus 1, so this is I plus v minus 1, so it's gonna be a minus equal to 1. And fi plus 1 is gonna be the last one, it's gonna be a plus 1. Yeah, else is the second case. I plus 1 is going to be plus 1. Fi plus 1 is going to be plus equal to 1. And f, let me just copy this one, I plus 1 plus n minus v, going to be minus equal to 1. Yeah, so this is the difference array. After that, we just need to calculate the prefix sum. So let me just accumulate all of them, the difference array. And finally, I want to check a maximum value, because I want to check the maximum score. Let me just use a max. It's going to be the maximum of the prefix. Now I just need to enumerate all the values. Enumerate the prefix. So if this value equal to the maximum, I just need to return the index. Yeah, because this index just means the rotations. Yeah, let's just try to understand that. How many rotations, it is just dependent on this index. So for example, if at index 3, maybe here at index 3, this is the maximum value, and basically for this index we're gonna rotate it to the first position. It's gonna be 1, 2, 3. Yeah, so we just need to return this index. This index just means this k. Yeah, the smallest index k, we can rotate it, because basically we need to rotate this index to the beginning. Beginning is 0, so it's going to be 3. Yeah, we just need to return this index. Now let me just run it to check. Here is a typo. Let me just run it. So the list index go out of range. Yeah, here should be I minus v. I did a wrong calculation. I think for the difference array, if we did some wrong calculation, definitely it is wrong. I think I explained right, but I just recorded a wrong formula, a wrong calculation. It's going to be I minus v, because yeah, this is the second case, because for the first case, let me clean up a little bit. Yeah, because for the first case, if we like have 1, 2, 3, 4, 5, let me just prepare this one, and here gonna be 2. Yeah, and for this kind of case, basically my formula it should be 4 minus 2. Yeah, it is not plus v. I think I explained it right, but I recorded it wrong. This is why here it go out of range. It's gonna be I minus v plus 1. It's gonna be I minus v plus 1. Yeah, because in this example, as we can see that, so this is I index 4 minus this 2. It's gonna be 2 because we have basically we're gonna have 3 ones first from the beginning. Yeah, so this means it's gonna be it's gonna be go to the index 3. It's gonna be here. Yeah, here gonna be index 3, and this gonna be 0. Yeah, so this is I minus v plus 1. Now I think the second formula should be okay. Let me just run it. As you can see, it works. Now let me just submit it to prove it should work. Yeah, as you can see, it works. Basically, for this kind of a question, we have to make a drawing to find the positions where we can use the difference array to solve the problem. And this is an ON solution. Thank you for watching. See you next time.